Okay, so Google DeepMind, huh? You've brought in like a mountain of articles and research on them, even your own notes. It's like you want to really get under the hood of this AI giant.
Well, yeah, there's just something so captivating about this whole mission they have, like solving intelligence. It's not just, building a better machine. It's like they're trying to unlock the secrets of intelligence itself.
So less about building a brain and more about figuring out how brains work in the first place. Sounds ambitious.
Yeah, and you got to admire the boldness, right? Picture this. London, 2010. Three guys, Demis Hassabis, Shane Legg, and Mustafa Suleiman, start DeepMind with this goal: solve intelligence.
Okay, so that's the origin story, but I'm guessing this isn't some underground operation, right? When did the rest of the world start paying attention?
Well, fast forward just 4 years,
Mm-hmm.
and Google comes knocking with a check for, get this, somewhere between $400 and $650 million. That's not chump change,
Yeah.
especially back then when DeepMind was mostly known for, teaching AI to play old Atari games.
Mm-hmm. Yeah, I remember those headlines. It all seemed kind of whimsical at the time, like, oh, look, AI can play Breakout better than I can. But those games weren't just for kicks, were they?
Nope, not at all. This is where their whole approach gets really interesting. Those games were like a training ground for this thing they call reinforcement learning.
Reinforcement learning. Okay, you have to break that down for me a bit.
Sure, so think of it like training a dog, right? You don't program every tail wag.
Yeah.
You reward it when it does something right,
Yeah.
and it learns through that feedback, right? That's the basic idea behind reinforcement learning.
So they're basically letting these algorithms loose in a digital playground to figure things out on their own.
Pretty much. Except instead of fetching sticks, these AIs are mastering the intricacies of, well, pretty much any game you can throw at them.
That's really clever, actually. I mean, it makes sense. Games have rules, clear goals, a perfect environment for an AI to learn in. But how do you go from, say, crushing it at Pac-Man to, I don't know, solving real-world problems? That feels like a pretty big leap.
Right. But that's the beauty of this reinforcement learning thing and these super powerful algorithms they're building, especially these things called deep neural networks. They're basically creating AI that can learn and adapt in super complex environments. And get this, it doesn't care if it's a game world or, say, trying to predict how a protein will fold.
Hold on, did you just say predicting protein folds? That sounds a tad more complicated than beating Donkey Kong.
It is. And that's a perfect example of how DeepMind's work goes way beyond just games. I mean, that's fun for headlines. But this Google acquisition wasn't about entertainment. It was about giving them the resources to aim their AI firepower at some seriously big challenges.
So they've got this powerful AI, they're bankrolled by Google, and they're setting their sights on what, like saving the world. This is where it gets really interesting, huh?
Oh, absolutely. And this ambition was on full display in 2016 when DeepMind achieved something truly groundbreaking in the world of AI.
Hmm.
Yeah, so in 2016, we're talking about AlphaGo. This AI that didn't just play the ancient game of Go, it straight up dominated, even beat a world champion.
AlphaGo. AlphaGo. That does ring a bell. Wasn't there a documentary about it or something?
Yep. They even made a movie about it, and it actually captured how intense those matches against Lee Sedol were.
Lee Sedol, he was like the top Go player.
Oh, yeah. One of the best.
Okay, see, this is the kind of stuff that really gets me going about AI. It's like we're living in a sci-fi movie, right? Machines doing things we thought only humans could do. So back to AlphaGo, what made it so special?
Well, Go, it's not like chess, where you can just outcompute your opponent.
Mm.
It's way more complex, involves intuition, long-term strategy, the kinds of things we think of as, like, uniquely human.
Right, right. So how did AlphaGo manage to beat a human at their own game then?
Through that whole reinforcement learning thing we were talking about, basically, they let AlphaGo play millions and millions of games against itself, like a crazy amount of practice. It learned from every win and every loss, constantly refining its strategy.
So it basically became its own toughest opponent.
Exactly. And by doing that, it developed an understanding of Go that, well, surpassed even the best human players in the world.
That's pretty mind-blowing. And maybe a little scary, if I'm being honest. But okay, let's be real. Most of us aren't Go masters. So why does this AlphaGo thing matter to, like, the average person?
Sam, think of it like this. It was a watershed moment for AI. AlphaGo proved that AI could tackle problems that, for a long time, we thought were just too complex, too human. It was like, this isn't just some parlor trick. This is a sign of what's possible.
So a glimpse into the future of AI.
Exactly. And the best part is the stuff they figured out with AlphaGo, those principles of Reinforcement learning, deep neural networks, it's not limited to games. They're applying it to other really complex challenges, like, for example, figuring out this whole protein folding thing.
Okay, protein folding. Time for a quick biology lesson. I'm gonna need some help on this one.
Sure, so in simple terms, proteins, they're like the building blocks of life. They do
Yeah.
all sorts of important stuff in our bodies. And how well a protein does its job depends on its shape, how it folds into this complex 3D structure.
So it's like what origami, but with molecules?
Yeah, something like that.
Sure.
And figuring out how a protein will fold, it's super important for a lot of reasons, especially in medicine. Like if we know how proteins fold, we can design new drugs, understand diseases better, maybe even create entirely new proteins with specific functions. It's a huge deal.
Wow. Okay, that's pretty amazing. So where does DeepMind fit into all of this protein folding business?
Well, they created this AI system called AlphaFold, specifically designed to crack the protein folding code. And get this, in 2020, they made history. AlphaFold became as accurate as some of the most expensive, time-consuming lab experiments out there. They basically solved a problem that had stumped scientists for decades.
Hold on, seriously. That's huge. I mean, we're talking about potential breakthroughs in medicine, right? But here's the thing that always gets me. Who benefits from this? Does this amazing knowledge just stay locked up in some Google lab somewhere?
And that's what's so cool about DeepMind. They didn't just make this discovery, they made it accessible to everyone. They took AlphaFold's predictions for over 200 million proteins, that's basically every known protein, and just released it to the public, free for anyone to use.
Wow, so they're like democratizing scientific research. That's really something. They could have easily kept that under wraps, maybe even profited from it.
Right. But that seems to be kind of their thing, this commitment to using AI for good, to advance our understanding of the world and make it a better place. But not everything DeepMind does makes the headlines like AlphaGo and AlphaFold. They're also involved in some quieter but equally important projects, like their work with the UK's National Health Service.
Okay, the NHS, right? Big, important organization. But DeepMind in healthcare, that doesn't exactly scream front page news. What are they up to there?
So DeepMind in the NHS, huh? Not exactly the first combo that comes to mind when I think high-tech AI. What's the story there?
Well, they've been working together since 2016, kind of under the radar, on some seriously cool projects using AI to tackle some of the biggest challenges in healthcare.
So less about replacing doctors with robots and more about giving human doctors some superpowered AI assistance.
Exactly. And a great example of this is an app they developed called Streams. Now, this isn't like your Fitbit or something. This is specifically designed to help doctors catch acute kidney injury early on.
Okay, and maybe this is my non-medical brain talking here, but why is catching that so critical?
Well, acute kidney injury, it can be really dangerous, even deadly, if it's not caught and treated quickly. And the tricky part is, the symptoms, they aren't always super obvious, especially in a busy hospital environment.
So Streams is like an early warning system then.
Yeah.
It uses AI to spot those cases that human doctors might miss. Right. It analyzes patient data in real time, looking for those subtle patterns, those little red flags that might point to a problem. And studies have shown it actually works. Streams has helped doctors diagnose acute kidney injury way faster, meaning quicker treatment and, potentially saving lives.
Wow, that's incredible. But I'm guessing dealing with all that sensitive medical data, that has to come with some pretty big responsibilities, right?
Oh, absolutely. Anytime you're talking about patient data, privacy and ethics are paramount. And to be fair, DeepMind's work with the NHS hasn't been without its critics. Some people have raised concerns about how that data is being used, who has access to it, even just the transparency of the whole partnership.
Yeah, it's that classic tech dilemma, isn't it? Amazing potential for good, but also the potential for things to go wrong, even if it's unintentional.
For sure. It's a tough balance. But to DeepMind's credit, they've taken those concerns seriously. They've implemented stricter protocols around patient consent, made sure the data is secure, and are being more transparent about what they're doing. They even went and created a whole ethics research unit to really dig into these issues.
Wow, so they're basically building the ethical guardrails at the same time as they're building the AI? That's got to be a tough job. But it sounds like DeepMind's work goes way beyond healthcare, too. You mentioned earlier that they're even helping Google keep its data centers cool.
Yep, true story. They're using their algorithms to make Google's data centers, which are these massive energy-guzzling buildings full of computers, way more efficient.
Wait a second. So the same company that taught AI to master Go is now figuring out how to keep computer servers from overheating.
That's DeepMind for you. They love a good challenge, whether it's a complex game or something as, seemingly ordinary as saving energy. But that's the thing. They're always looking for elegant solutions to complex problems, big or small.
And I guess in the case of Google's data centers, we're talking pretty big, right? But is it actually working?
Oh, yeah. They've managed to cut down the energy needed for cooling by, get this, up to 40% in some of these data centers. That's huge, not just for the environment, but for Google's bottom line, too.
That's pretty wild. You know what else is wild? You said earlier that DeepMind is even somehow involved in the battery-saving features on my phone. They're everywhere.
It's true. DeepMind, they get around. And that's what makes them so interesting. Their work really pushes the boundaries of AI in ways that are, well, kind of awe-inspiring and, let's be honest, a little bit, unnerving at the same time.
No kidding. I mean, we've covered so much ground here, from mastering these ancient games to potentially revolutionizing healthcare to, like you said, making our phones a little less power hungry. It's clear that DeepMind, they're not afraid to ask some big, even uncomfortable questions about the future of intelligence and AI's role in all of it.
And those questions are only going to get bigger and more important as AI continues to evolve. I think DeepMind's work is a powerful reminder we're living in a time of incredible technological advancement, and it's really up to all of us to think critically about how we want to shape this future.
You know, couldn't agree more. It's definitely a lot to process. That's the thing about DeepMind. One minute they're figuring out protein folding, the next they're tackling energy efficiency. Who knows what they'll take on next? I'm both excited and, yeah, maybe a little terrified to find out.
Me too. It's going to be one wild ride, that's for sure.
And there you have it, folks, our deep dive into the world of Google DeepMind. We hope you've enjoyed this journey to the absolute cutting edge of AI. It's a complex and always changing field, and DeepMind is right there at the forefront, pushing the limits of what's possible and making us all rethink what the future might hold. Until next time, stay curious out there, and thanks for joining us on the Deep Dive.